During his second inaugural address on January 2025, President Trump announced an ambitious plan to send astronauts to Mars within his term. This announcement has certainly sparked a lot of excitement and debate. But will we really ever set foot on the red planet, where a year lasts 687 days? Let's check out. Following the Apollo moon missions in the 1970s, sending astronauts to Mars appeared to be the next logical step. However, it would be a giant leap, both politically and financially. Space is vast. While the Apollo astronauts reached the moon in just 4 days, traveling to Mars with current technology would take approximately 9 months. A complete mission, including the return trip when the planets align favorably, might last 2 to 3 years. During this period, astronauts would require food, water, oxygen, and protection from radiation. First off, let's talk about the distance. Mars is, on average, about 225 million kilometers away from Earth. However, this distance isn't constant. Both planets orbit the Sun, leading to varying distances. At its closest, Mars is about 54.6 million kilometers away, and at its farthest, it can be 401 million kilometers away. The first thing we need to understand is that traveling in space is all about managing energy. But what does that mean? Well, in this context, energy refers to the effort our launch vehicle puts in, and the maneuvers our spacecraft makes, using a certain amount of propellant. When it comes to trips to the moon, we have two common methods, the Hohmann transfer, and the free return transfer. The Hohmann transfer is often considered the most energy efficient for short trips, but it depends on various factors. Traveling to Mars is a bit more complex, because it's an interplanetary transfer, meaning we have to consider the Sun as the central body in our orbit. The key challenge is to manage the energy expense. Mars' orbit is more eccentric and tilted, compared to Earth's, and it takes longer to orbit the Sun. To plan a mission to Mars, scientists use a tool called the poke-chop plot. This is how a poke-chop plot looks like. This plot helps determine the best departure and arrival dates, and the amount of energy required for the mission. The poke-chop plot shows that opportunities for Mars transfers arise around every 25 to 26 months. There are two main types of transfers, a faster one that takes 5 to 8 months, and a slower, more energy-efficient one that takes 7 to 11 months. Generally, the trip to Mars takes around 9 months, similar to a human pregnancy. The problem with these calculations is that they measure the distance between the two planets as a straight line. They also assume that the distance remains the same throughout the journey. In reality, the planets move at different speeds in their orbits around the Sun. So, engineers need to calculate the best path for the spacecraft, aiming for where Mars will be when the spacecraft arrives, not where it is when it leaves Earth. It's like throwing a dart at a moving target from a moving vehicle. You have to predict where the target will be. Right now, the success rate for robot missions to Mars isn't very encouraging. Russia has launched 21 Mars missions, including 5 landers, but only 2 orbiters succeeded. The US has done better, with only 5 failures out of 23 missions. However, no mission has yet returned from Mars. Check out this infographic that shows the duration of several historical missions to the red planet. Sooner or later, humans will go to Mars, potentially within a few years, with the right political support. And one thing that can be done in the meantime is test human psychological resilience for such a mission. The longest spaceflight record is held by Russian astronaut Valery Polyakov, who spent 437 days in space in 1995. This tested the body's ability to handle muscle and bone loss due to zero gravity, and was also a psychological test of endurance. While contact with astronauts on the International Space Station is simple, as it takes only a fraction of a second to relay messages to and from Earth, radio signals take 20 minutes to reach Mars. So, astronauts there will feel much more isolated, adding to the psychological stress of confinement with a small team. Although it's a complex task, precise calculations and advanced tools can help ensure our spacecraft reaches Mars at just the right time. It's an amazing mix of science, engineering, and a bit of cosmic choreography.